Good afternoon. We've assembled for you a demonstration of how an automatic circuit breaker operates with additional status contacts and a fault contact. Here is a drive with automatic resetting, and attached to it is an additional status contact block. It can be installed with either one status contact or two. In this case, we have a status contact installed here to indicate the position of the circuit breaker. Plus, there is a fault contact and two status contacts, making 3 in total. We've assembled a circuit specifically set up to demonstrate the physical state during a short circuit. For safety, we're using 2.4 volts. We'll show once again how this will look physically when the breaker is reset. We've assembled a control panel. It shows the state of the circuit breaker, off, tripped, and the control buttons. We've supplied power, turned it on, and reset the actuator. The empty button immediately shows that it only triggers once. It has an unstable relay installed with an additional anti-bounce protection function. So no matter how many signals you send or how many times you try to reset it, it will always detect the current state. The green indicator light shows that the system is operating. There is no short circuit or overload, so it correctly displays the voltage. In this case, we've set it to 24 volts and installed a switch that allows us to realistically simulate a short circuit. The shutdown accordingly is done with a button, and it turns off as expected. Likewise, there is no bouncing, no repeated signals, and so on. None of that can happen. It will clearly have its own position, and when the circuit is disconnected, it's off. When it's on, it's on. When it's off, it's off. Now let's go further and simulate a short circuit. For example, our physical circuit breaker is off, but we can set it to either the on or off position and then switch it to the short circuit state. We've closed the circuit here, and that's enough for our purposes. I'll show you what happens, for example, when we turn it on. We turn it on, and immediately the circuit breaker trips, indicating a fault and showing the off state. Next comes a triple tripping sequence, with the first one lasting a few seconds. Pay attention, we specifically demonstrated that during a short circuit, when you turn it on, there will be no voltage here because the internal trip unit is working, and it shows a fault here. Accordingly, now the second switching cycle will occur, followed by the third. After that, the actuator will be locked so that the technician can safely come and work here. Why is this necessary? This is needed in case, for example, someone, maybe mice or someone else, or even with their hands, stuck something into the socket and a short circuit occurred. In this case, the circuit is essentially not broken, so that the master does not have to run around, turn it on there, and look for the shields. There, the keys to the shields drive it. It makes an imitation of recocking. If you determine that there is no short circuit, it supplies power. In fact, this was done additionally for these functions. You platoon. That was the third time. The second time. Accordingly, the third time, the delay is about 2 minutes, if I remember correctly. How many seconds exactly? You need to check the diagram. I'd like to point out that the small drive has the option to additionally install several contacts on the side in the state of the circuit breaker. In this circuit, a rather short handle with number 1 is sufficient. It can switch from 1 to 2, and the force is quite enough to cock it with the additional contact state. The indicator has worked, showing a fault here. The fault is indicated by the lamp. In this case, you can turn 2 lamps on or off, and you can separate them through a single block. In this case, we separate them through 2 blocks to show that both are working. Well, that's great. We've been waiting for this. So, as we can see, the mode has gone into lockout and is now also indicating a fault and disconnection state.